Okay, welcome back. So I asked you to go do 2 and 3, and here's 2. So if I look at 2, I have degree 2 and degree 1. This, I can try to factor it all I want. It doesn't factor. So I can always go check the discriminant. And when I do that, I get the square root of -7. So it does not have any real roots, no real roots. Okay? Remember, this has to be a positive number or 0. If it's 0, it has one double root, and if it's positive, it has 2 roots. They could be rational or irrational. So I take the bottom, I get x equal 3. That's this red line. There are no special squared terms. It's top heavy, so then, because it's top heavy, I'm going to do long division. I'm going to divide the denominator into the numerator. And the way I do this is I just say to myself, x times what gives me 2x squared? X times 2x gives me 2x squared. So then I take 2x times x and I write 2x squared. Then I take 2x times -3 and I get -6. Okay? -6. And then what I do is I'm going to take this polynomial and subtract this one. That's why I change signs. So 2x squared, take away 2x squared is 0. X plus 6x is 7x. Bring down the 1. Play the game again. X times what is 7x? X times 7 is 7x. -3 times 7 is -21. Change the signs, which I didn't even do here, and I'll tell you why. But you would change the signs and you would subtract down, and you'd get 22, which means you would have a remainder of 22, and if you remember back to your Algebra 2 days, that has something to do with it. It means that this will go into that with a remainder, but it means also that it's not a root, okay, the rational root theorem. Anyway, we don't care about the remainder. We care about this, and that's how I get this guy right here. So I get y equal 2x plus 7, which I graphed right here. It's got a slope of 2 and a y-intercept of 7, and that's 7. And this equates to 2, okay? Here's x equal -3. I also know that if I find f of 0, I get -1/3, which is right there. And that means that the graph is going to pass through here. So that tells me that my graph is going to run this way, and it's going to run this way, because it's going to chase these two asymptotes. And if my graph is here, then it has to be there. It will not be here. They're always going to mirror, especially with slant asymptotes. Okay, so that was 3. Now, let's move on to 4. Okay, and if we move on to 4, which is right here, again, I got degree 2 and I got degree, I didn't write it, degree 1. I foiled this out because it's top heavy. I'm going to have a slant asymptote, but this one also has 2 roots. So I gave it to you in factored form, and if I give it to you like this on a test, you're going to want to FOIL it out if it's top heavy. And so 3x times x is 3x squared. 3x times 2 is 6x. 1 times x is 1x. 6x and 1x is 7x. 1 times 2 is 2. Anyway, I do that, and I find my 2 roots. They're right here, -1/3, 0, and -2, 0. Now, I have an asymptote at x equal -1. I just set that equal to 0. There are no special squared terms. When I do my long division, I get 3x plus 4. X times 3x is 3x squared. 1 times 3x is 3x. Change the signs and add down. 7 take away 3 is 4x. X times 4 is 4x. 1 times 4, I don't care. Look, I didn't even write it. But I would write 4x plus 4, and then I would change signs and divide or subtract, and I get a remainder of -2. I don't care about the remainder, guys. This is what we want. And there's y equal 3x plus 4. All right. Now, I know I have a root here. I know I have a root here, and I also have a y-intercept here because I plugged in 0, 0, 0. 0 on the bottom leaves me with 1. I get 1 times 2 is 2. 2 over 1 is 2, so 0, 2. Tells me a whole bunch. Tells me that the graph is going to go through this point, and it's going to go through this point, and then it's going to chase. So I'm just going to draw that line, And then I'm going to run this one up here like this. And I'm trying to be straight, but I'm on my table with this crack in it. Just kind of messed it up. But, you know, it doesn't have to be perfect. But don't, you know, you want it to chase. You don't want to draw your line out like this. If you had your arrow going like that, you're going away from the asymptote. It chases the asymptote. And then we mirror it, guys. We also have this guy. So this guy's going to go just like this. And this guy's going to go just like this. And now you have your graph. All right, that's 3. Now 4 is a little more complicated. And I've already worked it up. I'm trying to make your videos shorter so you don't have forever to watch. Now, degree 3, degree 1. The other ones that have been top heavy have been separated by 1 degree. This is separated by 2. And if you're looking already at this, you'll see that I'm not going to get a linear function asymptote. I'm going to get a quadratic. Pardon me. So I factored out an x. And the reason I did that is because now I know I have a root. Okay? X equals 0 is a root. This does not factor. Okay? I can do b squared, which is 4 minus 4ac. 4 times 1 is 4 times 3 is 12. 4 minus 12 is negative 8. No other roots. This does not factor. Okay. So I take this, set it equal to 0. I get x equal negative 1. That's my vertical asymptote. No special squared terms. Top heavy. We'll come back to that in a minute. Plug in zeros all the way around. You get 0 on top and 1 on the bottom. Pardon me. 0, 0 is a y-intercept, and 0, 0 is a root. Now for this guy. So the reason I didn't factor this is because then you don't have to FOIL it out. But you need to use this, okay? And so what I'm going to do is I'm going to divide that by x plus 1. It goes x to the third, x to the second, x to the first, and if I wanted, I could put a 0 out here for 0x to the 0. But here's what we're going to do, because I actually bring that down here, and I bring this down right here. I'm going to ask myself, x times x squared equals x cubed. So x times x squared is x cubed. 1 times x squared is x squared. Change the signs. Add down. Notice that goes to 0. It's supposed to. If you did it right, then we end up with 0 right here. 2x, take away x. 2x squared, take away x squared gives me x squared. So x times x gives me x squared. 1 times x gives me x. Change the signs, add down. Again, you got 0 right here. 3 take away 1 is 2. 2x plus 0. X times 2 is 2x. 1 times 2 is, I don't care. I didn't even do it. See that? This is what I want. This is an asymptote, and it's right here, okay? So, yes, asymptotes can be all kinds of stuff. They are describing in behavior, and this is really a good practice to know how to find this. So, I know that my asymptote is a quadratic. I know a lot about quadratics. We were graphing quadratics not too long back. So look at what I did down here. I completed the square. Why did I complete the square? I completed the square because I want this guy. I just want to have a fairly accurate asymptote, okay? So complete the square. All right, so I did. I took half of b, which is 1/2. I took 1/2, I squared it, which is 1/4. I'm on the same side of the equality, so since I added 1/4, I have to subtract 1/4. I get x plus 1/2 quantity squared plus 1.75. Okay, so then I did f of 2. I plugged in 2, and I plugged in 2 just all the way up here, or up here. Okay, I just plugged it in, and I got 2 squared is 4 plus, hang on, did I mess that up? I might have made a mistake. Huh. Well, no, I plugged in 2 here for my quadratic. Okay, I'm sorry. I had the brain fart there for a second, guys. It happens. Okay, so I want to graph this orange graph accurately as possible. I want a couple of points. Okay, I looked up here at plugging 2 in, and that's not right. I want to plug in 2 into my quadratic. This guy right here. So when I plug in 2 and square it, I get 4 plus 2, okay, is 6 plus 2 is 8. So I got 8. So here's what I did. From here, I went over 2 and up 8. And over here, I went over 2 and up 8. And that gave me, I used symmetry. And I got to look at my asymptote. So the asymptotes on this thing go like this. Okay? And here's the other one. Okay? Running right down here. Like so. So if you look, our graph is here like that, and our graph goes through the x-intercept and chases. So I use this to figure this one out, and then you can plug in any old point you want. You can plug in -2. If you plug in -2 to here, you have to plug it into here. You're going to get a value, but it's going to tell you it's up here. Okay? There's no togetherness, so the graph can't be over here. Okay, there's no togetherness. Okay, so if it were over here, then it would have to be here, so it has to be over here. Okay, and if it were over here, then it would have to be here, and it's not there. So there's no togetherness. All right, now, example 5. Okay, let's go talk about example 5, and then we're going to stop the video again, and you're going to do example 6. And then you're going to come back and we're going to look at example 6 together. Example 5, a little different, isn't it? I'm giving you a graph and I'm saying use the given graph and work backwards to write an equation to model the graph. Use Desmos to verify your work. So when you're at home and you think you got it, let's go back and double check it. Well, first of all, right there I see a hole at -3. X equal -3 as a whole. Okay, the y value, I don't care that much about it, but I do care about this. Because if x equal -3, the only time we have a whole is when we have the same factor above and below, and they cancel out. When I say above and below, I mean in the numerator and in the denominator, we have a factor that will cancel out. Well, if x equal -3. Let me back this bus up. If I know that x equals -3 as a whole, then x plus 3 is the factor. How'd I get that? I just worked backwards. I added 3 to both sides. And I know you did stuff like this in Algebra 2 last year. So you add 3 to both sides, you get x plus 3. I think I'm okay right here. Okay? X plus 3. Okay, do I have any roots? Hey, I do. Look, right here, I have a root at 0, 0, huh? No, it's not. It's at 2, 0. So x equal 2 is a root. Okay. What does that mean? That means x minus 2 is a factor. Again, I'm working backwards. I'm starting with my root as x equal 2. So here's what I know. I know a root and I know a whole. And do I have a y-intercept? Oh, right there. I didn't put the y-intercept on here. That is my fault. Dadgummit. Okay. Well, I didn't. I'll fix it on your worksheet, but I happen to know what it is. Here's 1, and here is, it's actually 1/3. The y-intercept is 0, 1/3. Okay. So, moving right along. I know that I have a root at x equal 2, so x minus 2 is another factor. Okay. Now, I also know that y equals 0 is a ha. Okay. So y equals 0 is a ha. What's a ha? A horizontal asymptote. What does that mean? That means that it's bottom heavy. How do I know that? Because if it were balanced, it would be up here at y equal 2 or y equal 1, my ha. But my ha is y equals 0, so that means it's bottom heavy. Okay? Bottom heavy. All right. Now, what else do we know? This is x equal 3, and it's a VA, okay? This guy over here is x equal 1, and it's a VA. So for my asymptotes, I know I have x equal 1, and I know I have x equal 3. So this is x minus 1, and this is x minus 3, and these are factors. Okay, so I got x minus 1, and I got x minus 3. All right, right now, what I have is I know that this is a whole, right? So it's not going to factor into my y-intercept. And my y-intercept, which means the top equals 1 and the bottom equals 3. When I plug in when x equals 0. Okay, we're going to come back to that. Do I have any tangents? No. Do I have togetherness? Yes. Together at x equal 3. This is togetherness is always bottom special squared term. So at x equal 3, which happens to be x minus 3, that's going to be squared. Do you see how I got squared? It's chasing, it's together right here. Okay? And there's no bounces. It passes through here. This is a hole, but it doesn't get to the x-axis anyway because there's a horizontal asymptote. So right now I got degree 2, and down here I got degree 4, don't I? Okay. Well, if I have a hole, they don't count in my y-intercept, do they? Recalling from memory, I'm pretty sure that's 1/3, but I'm thinking it's something's not right here. Dang it, I messed up on my y-intercept, guys. I forgot to put it in there. I thought it was 1/3. If it was 1/3, then if I put in 0 here, I get 2/9. It's 2/9. We're going to change this just because I forgot to put it on here. So I want you to know how, so I will label that on your homework. And I'm pretty certain it's all labeled because you got a couple of these on your homework. That's got to be 0 2/9. And if it's 0 2/9, I'm going to get -2. If I plug in f of 0, this doesn't count, it's gone. So I'm going to get -2 over negative times a positive over -9, which is 2/9. It was 2/9. It wasn't 1/3. It's 2/9. Okay, this is your function. This is the way you write your function. Okay, if you graph this on Desmos, you will see this graph. You better see this graph. And what you should be doing on Desmos is you should be graphing x equal -3, or 3, x equal 1, y equals 0. Put in your hole and label your x and y intercepts. I did not label these. I apologize. There is only one here. I know that. So I want you to stop the video, and I want you to go work this graph and see if you can't come up with this equation. Give it a try. It looks super busy, but if you think about what I did up here and just go step by step just to get you started, x equal -4 is a VA. X equal -2 is a VA. X equal 3 is a VA, which means right here, you're going to go x equal -4, x equal -2, and x equal 3. You have a root and a y-intercept of 0, 0. That tells you a bunch. That means that I'm going to, for a root, one of my factors has got to be x. So I know I have an x up here, okay? Because that's going to be 0. And then whatever other factors, when I plug them in, it's going to be 0 times something. I can have 0 up here, but I can't have it just an x down here because I can't divide by 0. Do I have any togetherness? No. Do I have a tangent? Yes. Tangent at x equal 0. I guess I was going to tell you to turn it off and work it. All right, now pause it and go work it. I'm going to continue working. When you come back, you can just follow me. Okay. It is bottom heavy. How do I know that? Because it's y equals 0. Right there. Y equals 0. All right. And I got 0, 0 over here. Well, this x equal -4 is going to be the factor x plus 4. This is going to be the factor x plus 2. And this is going to be the factor x minus 3. And these are all in the bottom. One of the reasons I like you to write these equations from the graph is they make you think about all these things. So x plus 4, there's no particular order here. X plus 2 and x minus 3. Okay? All right. Now, keep going. I got a root at x equals 0. Okay. I have tangent there. That has to be x squared because it's tangent. All right, I'm thinking. So I have to apologize on number 4. Dadgummit, I made some changes to the lesson. The y-intercept is 2/9, and I didn't label the y-intercept and this root, but this is the function. Okay, I have little lines through these two only because they're my whole, and I used that to make sure that this was 2/9. Okay, now down here, we started setting this one up, and we said x equal -4, x equal -2, x equal 3. That should get you these 3, no doubt about it. Okay, this is both the y-intercept and the x-intercept. Okay, and this graph comes up, bounces, and goes down. There is no togetherness. If there was togetherness, there'd be a graph here, or there'd be a graph here, or there'd be a graph here, you know, etc. There's no togetherness. So tangent is the top, and togetherness is the bottom. So this would be togetherness down here. And guess what? There is none. There is none. So that means the top has a special squared term, and it's at x equals 0, so it's x squared. That's how I got x squared. Okay, now nothing else is really sticking out here. Actually, I think number 5 is harder than number 6 because you got more thinking to do when you're doing your y-intercept right here. But if you double checked these on Desmos, and when you do this, you should have this function in one of the equation markers. Then you should have 2, 3, 4 equation markers. Okay, you should have 4 equation markers, y equals 0. So that should be 1, 2, 3, 4, 5. And then if you label this, then that would be 6. Okay, so this is your homework. Worksheet 3 is Monday's, well, actually it's Tuesday's assignment. And summer camp, I have to make that video next, will be for Thursday's homework. All right. Talk to you Thursday.